Hello, my name's Ryan and my project is support vector machines hardware acceleration on PYNQ. So this project was inspired by research where we were looking at classifying hyperspectral images of bacteria for helping to tackle antibiotic resistance. And here's an example where we can classify some unknown data from known training data. Hyperspectral images capture data at hundreds of wavelengths, and SVM is one algorithm we can use to train and deploy a classifier, and my project looks at using hardware acceleration to accelerate both phases. And the motivation for this was perhaps for use in an embedded imaging system, but this could have many other applications. To design my hardware, I used Vivado high-level synthesis, and here's an example of my project architecture, where I'm training and deploying multiple classifiers in parallel. Now I'll give you a quick demo of my project running in hardware. First of all, this is the hyperspectral dataset that I'm using. There are 3 training classes and 3 unknown testing classes. You can see 3 distinct clusters, and we'll pass this data to the hardware to generate the training model. We now load the SVM training driver class and then call the top level function, which passes the relevant data to the hardware to compute the training model. So here's the result. It's 3 planes which separate the 3 pairs of classes. So next we view the testing data. So the colours here indicate the actual classes. So similarly to before, we load a driver for the SVM deployment stage, and there was an 80% accuracy. So here you can see the training model and the actual classes, and if we select the predictions, you can see some misclassifications, particularly with the blue class, and that explains the 80% accuracy we saw. You can see the SVM deployment hardware design was substantially faster than software, whereas the training design was slower, and I've identified the reasons for this in my report. Overall, I'm really happy with my design and its performance. Thanks a lot for listening.